Kachow. Hey guys, let's get right into the convo. Kachow.
Physics. Vector resolution. Vector resolution is used on the incline plane and in projectile motion. What is resolution? Resolution is splitting a vector into its two components. So how do we do this? So you have your vector going off into space, like that. So your vector is in the xy plane. That's x and that's y. In the xy plane it has the x component, or the y component, and the x component. So the way we do this, if you have your vector going that way, your angle, then that's going to be your x, your y, that's going to be your x. I'll label this one red to make sure it's the resultant of the two. So you find the components by doing, so find the horizontal cos theta, vertical is sine theta. So let's take an in-depth look at inclined planes. Inclined planes. Example of an inclined plane question is when they would give it to you, you have a box sliding down a ramp. That's your angle theta. Here's your object. Now, the forces acting on your object, you have the normal force, which is the reaction force with the ramp, or slope. So we'll call that F norm, and that's always going to be perpendicular to your slope. Then you have its weight, which is down, and that's mg. Then there's the force parallel to the slope, so let's make this nice parallel line. And there's a force perpendicular to the slope. So call that F parallel, F perpendicular. Now, F norm and F perpendicular cancel. So F perpendicular equals F norm. F parallel is equal to mg sine theta. F perpendicular is equal to w cos theta, which is the same as mg cos theta. So how do we arrive at that? So your angle theta is there. we know that because of parallel lines, using angle theorems, if we have one line there and there's two parallel lines here, that angle is going to equal that angle, and that angle is going to equal that angle. And so we can do the same thing here. So if we have that going in there, let's redraw our inclined plane. We have theta. We have our object. So let's draw in its way. So that's mg. So and then you can say that the parallel is just one of the components of the weight. So the parallel goes like this, and the perpendicular is there. And we know that these are going to be at right angles to each other. So let's redraw this triangle now. So we've got parallel, perpendicular, mg, F parallel, F perpendicular. So how are we going to relate this to our inclined plane? So from our formulas, we know that the F parallel is the sine theta between mg and that. So we know that mg is our hypotenuse, so this triangle has been drawn out of proportion, so let's redraw that. So we have mg as the hypotenuse, so F parallel, F perpendicular. Well, if we now look at our inclined plane is this triangle. That being theta, and that being the right angle. So the hypotenuse, adjacent, opposite. So we can see that these are two similar triangles, and so if we follow that, then theta goes here. Alright, let's look at projectile motion. Projectile motion. Alright, so first we need to define a projectile. So a projectile is a powered object, an unpowered object, in flight under the influence of gravity. So an important thing to note is that projectile has to be unpowered. Has to be unpowered. So a rocket would not be a projectile because it's powered, but if you threw a ball, the ball would be a projectile because it's not. Apart from the throw, there is no more power going into it. So let's look at how vector resolution helps with this. So projectile motion has also got two components. So it's got the horizontal component, which is in the x direction, and the vertical, which is in the y, same as before. So when you're throwing a ball, boom, 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 it's going to have a maximum height, which is going to be determined by the y, and maximum distance, which is going to be determined by the x. So let's break down these different components. So if we look at the acceleration in the x direction, well, it's 0, because there's no external force acting on it because we are neglecting air resistance or friction. The velocity of x is a constant. This is to obey with Newton's first law of inertia. And so you can say Vx equals Ux. And Sx is Vxt. Now I'm not going to put an x next to the t, and we're going to see why now. So let's look at the vertical. So Ay, negative 9.8. It's accelerating downwards at 9.8 meters per second. Vy is equal to Uy plus Ayt. Again, not Ty. And Sy is equal to Uyt plus Ayt squared on 2. So now why haven't I put Ty and Tx? Well, that's because they are the same. So your T is constant. And it's what links together all of it, and it's how we can do calculations which help us. So, as we said before, so the horizontal component finds the range. And the vertical component finds the time of flight. So generally you use the vertical component to find t, and then use the t to find the range. However, you do get questions such as, if you fire a cannon, will it be able to make it over the wall? So this is when the Sy comes in. So the Sy is going to be the distance that it travels upwards. So it's going to make a parabolic pathway. We know this from the quadratic formula that we have with t squared. Alright, so here we have a question where the vertical displacement is not 0, so it's not being thrown and landing at the same height. So let's look and see how we're going to deal with one of these questions. So always split your page up into 2. So we have the y and the x. So let's see what we have. So we have uy, we have ay, we have sy, we don't know t, and we don't know, and we're trying to find the range. Alright, so what is uy? Uy is 25 sine 22. We know that from the information given at the top of the question. Ay is always negative 9.8. So how are we going to work out sy? Well, sy is negative 3.2 because it's dropped 3.2 meters up to 0. So its displacement is negative 3.2 because it's gone down. If we were taking r down as positive, it would be 3.2, but ay would be 9.8. It's always important to remember that. So, how are we going to find the t? Well, we know that s equals ut plus at squared on 2. But then we're left with a quadratic, so we don't want to use that. So why don't we try use v equals u plus at. It's not a quadratic, however we don't know this v, so how can we work that out? Well, we can say vy is equal to uy squared plus 2as. We know all these variables, so let's plug them in. So that's the same as 9.37 squared plus 2 times negative 9.8 times negative 3.2. So, and that's v squared. So v would be the square root of that, and that comes out to be plus or minus 12.27 meters per second. We know it's traveling downwards, so we're only going to take the negative of this. So, if we got v equals u plus at, then we know that t equals v take u on a. So if we plug in our numbers, we get out 2.21 seconds. So that's the time of flight from when it leaves his hand to when it hits the bottom. So now let's look at the x. Ux, we know. We know t. We can find Vx, because we need that to find Sx. So Ux is 25 cos 22. T is 2.21. Vx is equal to Ux. And then Sx is Vxt. So Sx is 23.18 times 2.21, which is equal to 51.23 meters. Therefore, the range is 51.23 meters, or 5.12 times 10 to the 1 meters.
Oh, Kachow.